Jai Hind student, I am Madhup Agrawal from AKGEC Engineering College, Assistant Professor in IT Department. Today's our topic is recursion. Recursion is a topic which is very important in programming language, and here we are considering the Python programming. We will see recursion with respect to the Python programming, but basic concept will be same as in other programming. So, first of all we see what is recursion. So, recursion is a method of solving a problem when the solution depends on the solution of a smaller instance of the same problem, or we can say to solve a bigger problem. To solve a bigger problem, we divide it into the same type of small problem, smaller instance. Same type of small problem are known as smaller instance of the main problem. We will see, just see the example of factorial of a number n. Okay, factorial of a number n. What is the factorial of number n? That is the, see, factorial of n equal 1 if n equal 0, or this is n into n minus 1, n into factorial of n minus 1 otherwise. Means when we are solving the problem, main problem factorial n, then in the definition part, means we are saying what is the factorial n. So, we are saying the factorial n is the n into factorial of n minus 1. Okay, means we are defining the factorial in the form of factorial itself. So, this is a recursive type of problem. Yes, we are describing the problem in the same type of sub problem. So, this is the recursive approach definition of this one. Now, recursion implementation. In programming, recursion technique is simply implemented by function or procedure. So, how to implement the previous concept, how to implement this particular recursive concept with the help of the function in the programming, function or procedure in the programming. So, this is the definition regarding the programming concepts. So, when a function call itself from their own code is known as recursion. This definition is with respect to the programming approach. So, when a function call itself is known as recursion, this can be directly or indirectly calling. Now, factorial of the number. How to implement the factorial of the number in the programming? So, as we have seen already, factorial of n equal 1 when n equal 0. This is known as the base condition. This is known as the base condition or termination condition, and factorial of n equal n into factorial of n minus 1 otherwise. So, the same thing is written in this form. This is in the form of function. We are defining the function factorial. So, here in the mathematics we are giving the sign that is factorial. This, or we can also define this sign in the factorial, but in the programming we are using the concept of recursion using function. So, we are writing this in the function form. So, fact is the name of function and n is the parameter which are passing. So, same, this is 1, this is 1. If n equal 0, this is condition. If n equal 0, base condition. Otherwise n into factorial n minus 1. So, when a function call itself, means here the function is fact, and in the definition part fact is calling the fact itself. So, this is a recursive definition. Recursive definition here point to be noted, this parameter is n and this parameter is n minus 1. Both parameter cannot be same. So, this is in decreasing, this is decreasing, and at the point this will touch the this particular termination condition. So, just take example, we will see. Just first take example. If we write the factorial of just let 3, so factorial of 3 will be in it, this is not the base condition match, factorial here n equal 3. So, this will run, means 3 into factorial of n minus 1, 3 minus 1, 3 minus 1 means this will be 2. One another function call factorial, this will call another recursive. So, this is equal to 2 into factorial 2 minus 1 equal 1, base condition noted here, again f call 1 into factorial for n minus 1, here current n is 1. So, 1 minus 1 0. Now, this is the base condition reaches n equal 0, here n equal 0. So, this will return this particular one, here 1 will return. So, in this form a recursive call. So, how much depth will go on, this is dependent on the this base condition, means base condition or termination condition must be met, otherwise infinite recursive call may be there. So, to prevent the infinite recursive call, we have we must reach the this termination condition. Now, see, now convert it into the programming part in the code, just like here we are using the Python code. So, in the Python programming we are converting this concept, this particular concept into Python programming. So, this is the function definition. In the Python we use the def keyword to define a function, here def, then fact is the name of the function, then parameter, then colon sign. Now, this is the body part of the function. Now, first we check the value of n with the help of this particular base condition here, if n equal 0. So, here if n equal, this is comparison operator. So, we will assign double equal to n equal to 0, n equal to 0, then what to do, then return this particular value, then return this particular value with the help of return statement, return 1. Otherwise what to do, otherwise means in the else part, what to do, this one, n into fact n minus 1. So, return what, n into fact, here the fact name of the function, and parameter is n minus 1, n minus 1. So, here this is the recursive function call, because fact is calling itself fact function. So, here we see for any particular recursive problem, first we write the this particular definition, means mathematical definition. If we write the mathematical definition, then just convert this mathematical definition into the particular code of the language. So, here just converting in particular language using the syntax. Now, take another example, we will take the factorial, just we have seen already here driver code. Now, the driver code, how to call the this particular function. When we call the function, then this will perform some particular task. So, first receive the input from the user, enter a number, we will save it into num parameter, and then call the particular factorial and pass the num as a parameter. We will receive here in the n and perform the task related to this particular concept and return the value and save it into the particular parameter f and print the factorial value which is in the f variable. So, our output just one output is here. Case enter a number. If we give the number as 4, here we receive enter a number. This line executed, enter a number, we will receive the 4 into the num, we will receive 4 into the num parameter. Now, this particular 4, here we are calling the function fact. Now, in the end we will receive the 4, and condition check n equals 0, this is false. Now, this is false, else part will be executed, means return what? Return this particular one, means return here, return 4 into fact n minus 1, n minus 1 means this is 3. Okay. Now, for this particular function call, now n is 3, which code will be executed? This particular one, else part code, means again here return this is 3 into fact, this is now 2, again a recursive call for this particular n, which code will be executed? This particular else part again. So, here return now n is 2, 2 into fact 1, now n is 1. So, for n is 1, else part will execute. So, this is here return 1 into what? Fact 0, fact 0 here. Now, for now n is 0. So, for n is 0, if block will be executed. So, this will return 1, return at the place of calling, this will return 1. Now, calculate stop the recursive calling here, and 1 into 1, that is 1, and return 1, return to its caller, means here at this place we will find the 1. Now, calculate this one, 2 into 1, that is 2, return 2, we will find 2 at this place, 2. Now, return what? 3 into 2, that is 6, we have to return its calling point, we call the fact 3 from here. So, we will get 6 at this point. Now, 4 into 6, that is 24, 24 we have called from here, we have first time call f equal fact 4. So, we have called from here. So, this is 4 into 6, that is 24, 24 we will get here, and we will receive in the f parameter here. So, here we will receive the 24 in the f variable. Now, factorial of, we will print factorial of 4, factorial of num, in the num 4, factorial of 4 equal the value of f, value of f is 24. So, we will get 24. This is the whole sequence of recursive call. We must reach at the base condition and then track back to the initial call and get the answer. We will see here also recursive call concept, and we will get the result 24 here. Now, the content of the recursive function, as we have already discussed, there must be a base case, means value of the input variable for which we perform no recursive call, are called the base case. There should at least one base case must be there, at least one base case, maybe 1, 2, 3 or many base cases, but at least one base case must be there. And the recursive call to the current function is known as the recursive call. Each recursive call should be defined so that it makes program towards the base class, means on the calling of the recursive we have set parameter, different parameter, just like in the case of this one, when recursive call is for different parameter. Here parameter is n and here n minus 1. Why n minus 1? Because this is approaching towards the base case. Base case, our base case was n equal 0. This was the base case here. So as time goes, value decreases and made to the base case. Now take another example. A power b recursive function, make the recursive function for a power b, means exponent. So first a power b means a into a, how many times? B times. B times. This is a simple definition, or we can say this is just like a into a power b minus 1. Here total number of terms remaining, we have filter one term and remaining b minus 1 term, means we can say a power b equal a into a power b minus 1. So here we are defining this is the main problem, a power b, how to calculate by using in its own term. We are defining a power b in the a power b term, means a power b minus 1, means exponent in the exponent form. We are defining exponent in the exponent form. So our recursive definition is this one. Okay. Here base case is missing. Now base case must be there. So what is the base case? This is the base case. If b equal 0, means if a power 0, any value having power 0, means that the value is will be 1. The value is 1 here. This is the base case. Otherwise the value is a into a power b minus 1. So this is the mathematical definition of a power b, recursive definition, mathematical recursive definition of a power b. Now convert this into the corresponding programming code. We are using here Python, so convert it into the Python. In the function form we write the same thing as here. This is the function name myexp and two parameter a, this is the b exponent, and we write here in this form 1 when this base case matches, otherwise a into my exponent, same function my exponent for the different parameter a power b minus 1, a power, this is the one parameter, this is another parameter. So a b power b minus 1, a b minus 1 otherwise. So convert this code into the programming syntax. Now define myexp parameter, two parameters, here two parameters, and this is function definition, so quotation, and first write the base case. Here the base case is this one, if a equal, if b equal 0, if b equal, again comparison, so double equal to b equal 0, we are following the syntax of the particular language. So b equal 0, then our value is 1, then return 1. Otherwise means in the else part, what to return? Return this one, simply return simply this one, a into function call myexp, same function, and the parameter is, first parameter is a, now a, and b minus 1, then b minus 1. This is the recursive program for exponent, recursive function mainly. Okay. Now same thing, the complete whole the program. Now driver code, with the driver code we receive the parameter from the user and save it into base, input, enter the base, enter the exponent in the exp parameter, and now we are calling the function myexp base and exp and receive the parameter is just enter base. We run the code and this is the instance of this particular. Simply our code will run from here. Driver code, first line is this one, this will print enter base, enter base. We have given base is 2. Now the value of base, is 2. Okay. Again enter exponent, we given the 4 is received in the exp is 4. Now this function call myexp and base and exp as parameter, we will receive this particular 4 into a parameter and b 4 into the b parameter. Now if b equal 0, no, b is not 0, b is 4. So else part will be executed. In the else part, here return a means 2 into myexp, the parameter is 2 and this is b minus 1. Why b minus 1? Because this is approaching to the base case. B minus 1 means b is 4, b minus 1 is 3. Again a recursive call for this particular function myexp. Again b is not 0, so again else part myexp, this is 2 into myexp, this is 2 and this is 2, b minus 1. Again recursive call, this is 2 into exp, this is 2 and 1 decrease, and again this is a into, now a is 2 into myexp and this is 2 and decrease 0. Now base case reaches b equal to 0, In the case of b equal to 0, we will return this particular one, we will return at this point 1, we will get 1 at this point. Now 2 into 1 equal, here return also here, 2 into 1 that is 2, we will get 2 here. Now 2 into 2 that is 4, here return, we will get 4 here, Now 2 into 4, here return to its calling function. So 2 into 4 means we will get 8 here, we will get 8 here, we will get 4, 8 here, we will get 8 here in this part, we will get 8, and now 2 into 8 that is 16, we have called from here, function called from here. So we will receive val, equal what, 2 into 8 that is 16, we will get 16 in the val. So here now print base power means value of base is 2, power exp is 4 equal val is 16 to power. So with the help of recursive call we will get the answer, exponent answer. Now we will see in the slide myexp 2 power 4 in the same manner. Just see here, 2 into exp3, again function call, new call will be generated, 2 into this particular exp3, now again 2 into myexp, decreasing, b is decreasing. Now we will reach to the base case, our base case was b equal 0. At this point we will get 1 and 1. Now we will find 2 here, 2 into 1 that is 2, this is 2 into 2 that is 4, we will get 2 into 4 that is 8, and in this case 2 into 8 we find 16, the final answer. So we find the final answer at the first call, at the point of the first call when we have received. This point to be noted. Now another examples, same here, two base classes. Just this is Fibonacci series. Fibonacci series, as we know, the previous two terms sum generate the new term. Just Fibonacci of 6 equal Fibonacci of 5 plus Fibonacci of 4 term. Fifth term is 3, 4 term is 2, 2 plus 3 is 5, and Fibonacci of 1 equals first term is 0, then 0, 0, this is first term, second term, this is third term, this is the base case. How to get third term? 1 plus 0 equal 1. Now how to get fourth term? 1 plus 1 equal 2. How to get fifth term? Previous two term addition. Our previous two terms are 1 and 2. 1 plus 2 equal 3. Now sixth term, previous two term addition. The previous two terms are 2 and 3. 2 plus 3 equal 5. We will get the 5 here. So in the programming concept, if we have written if n equal 1, we will get 0. If n equal 2, we will get 1. We will get 1. Here two base cases, this and this. Otherwise, we will get the n minus 1, value of n minus 1 term, and Fibonacci of n minus 2 term we will get. So this is the recursive definition of Fibonacci. Just convert it into code. Fibonacci in the previous case, two base cases, if n equal 1, then return 0. If n equal 2, else if n equal 2, return kya? Return what? Return 1. Else, otherwise, else part, return what? Return this one. Return this one. We have right here, return this one. Our function is ready. Our recursive function is ready with the help of this one. Means main part of the function recursive, main part of the recursive definition or recursive programming to make this mathematical definition. And here just convert into the particular language syntax. Now the same program, here we have given the driver code. Our driver code receive the parameter in the enter the number of terms. Then for number of terms, we are using the for loop and generate the series enter number of terms 6. Here 6, we have received 6 in num and loop from 1 to 6. 1 to 6. So 1, 2, 3, 4, 5, 6. We have generated all the terms. We have generated first time fib 1. In the case of fib 1, function call. In the case of fib 1, base case met, fib 1 return 0. We get the 0. Come in the calling function again for the I equal 2. Now fib 2 is called. For fib 2, function is called. Here we made the base condition n equal 2. Then return what? Return 1. We have get here 1. Okay. Now again for this one, fib 3 is called. Fib 3, for the fib 3, we have executed this one, means fib, this is 2 plus fib 1. For fib 2, we get the 1, and for fib 1, we get the 0. 1 plus 0 equal 1. So we get the 1. In the same manner, we get the term number 4, 5 and 6 as series program. So fib 4 in the picture we can see the Now the data structure to implement. So main data structure is stack. How to implement in programming? By using stack we can implement the recursion. Whenever a function call another function or itself as callee, the caller function transfer execution control to the callee. We have seen already. The caller function has the suspend its execution temporarily and resume later when execution control returns from the callee function. We have already seen callee and caller function. The caller function need to start exactly from the point of execution where it puts itself on hold. Okay. So transaction between callee and caller function, and for this purpose an activation record means we stack frame is created for the keeping the record from return where the return point is and what will be the value of this particular call, all are kept in the activation record, and this activation record is maintained using the stack frame. Okay. These are some analysis of recursion. Time complexity. Time complexity is O and n recursive calls, so n time complexity will be there. Space complexity, many stack frames are created. If for each call activation record is maintained, so this is a, we can say this is a negative point. Space complexity counted when amount of extra space required for module to execute. In case of recursion, the system need to store activation record each time a recursive call is made. N calls, n records will be maintained, so extra space is required. Now all about the recursion, and one point is tail recursion. This is another technique of recursion in which we get the output, final output at the base case, not at the first call, at the last call we will get the result, and this is known as a tail recursion. In tail recursion we get the final output on the base case or tail. The tail recursion is basically using the recursive function as last statement of the function. We can make function tail recursive by adding some parameter, the parameter that are known as accumulator in function signature, means we need one extra parameter to maintain the tail recursion. Just see example here, extra parameter are equal 1 accumulator, and we are getting the output here, return or final output. Okay, and we are calculating the intermediate parameter here. Just in the case, no need to create new stack frame. This is the plus point, a advantage. We not need to create the stack frame, means not keep the previous stack frame. Only one stack frame is required to keep the tail recursion. Just see here, 4 1. We are finding the factorial of 4, and this is the r. Now this is decreases, and we are calculating 4 into 1, that is 4 here, keep here. Now again in the next call decreasing one, this one, and as a accumulator 3 into 4, that is 12. Now again decreasing this one as in the factorial, and here 12 into 2 is 24. Again decreasing this one, and the next is 1 into 24, that is 24. This is the base case, and at the base case we are returning the second parameter, that is r. So we will get the output at this one. No need to backtrack here, no need to backtrack. We will get the final output here, so no need to maintain the previous activation record. So only one activation record is needed in the tail recursion. We will get final output. Okay, thank you.